Hello and welcome to Physics Ka Doctor. My name is Dr. Ghanshyam Tejani and let's start chapter number 14 Oscillation. The content is also in JEE NEET unit number 10 Oscillations and Waves. And our next chapter will be on waves. This is session number 3 on simple harmonic motion, and in the session number 1 and 2 we solved up to 1 to 12 examples and the basics of simple harmonic motion and two equations and examples and methods. We did many things, and also we are covering previous year NEET questions. In the subsequent sessions, we will be having JEE questions also. Let's see. So our first question, it is example number 13. Which one of the following equations of motion represents simple harmonic motion? The question was asked in All India Pre-Medical Test 2009. First is minus acceleration equal to minus k0x plus k1x square. Second is acceleration minus k in bracket x plus a. Acceleration k x plus a. And D is acceleration kx. Where these are the positive, k is positive. Okay, fine. Now let's see. In the simple harmonic motion, we already know that there is a acceleration velocity. Graphs are there. And we know that x is equal to a sine omega t is a general equation. And if you want to derive this acceleration, we need to differentiate. So velocity is equal to a omega should come here. Sine become cos. So a omega cos omega. And how about acceleration? Again differentiate. Let's see. So a is equal to cos becomes sine, so it becomes minus omega should come on outside. So a omega square sine omega t. And we can put the value of a sine omega t in this equation, so it becomes minus omega square x. And see, this equation even we memorize, right? A is equal to minus omega square. Right. Now let us compare the first equation, equation number A, where acceleration is equal to minus k0x plus k1 x square. If you see here, there is only x, there is no x square, there is no x square. Do we see any x square? No, there is no x square. So this equation A is not satisfying. It is not satisfying. A is wrong answer. B, let's see what is given in the B. B, acceleration equal to minus k x plus a. If you see our equation, so minus k means omega square, that is a positive value. Minus k we can consider as omega, and here x plus a. We can, so it become x kx plus, or you can say minus ka. It's a constant, right? It's a fixed value, positive value, so it is not bothering. We need not to bother about minus k. So it is very similar to a omega square. That means first one is incorrect, but second, yes, it is possible. What about third? In C, acceleration is given kx plus a. Can write, so it gets kx plus a. This is constant, okay, but see, this term should be negative, but here it is positive, so it is not near to that. So C is also not possible, not A is not possible, B is yes. C, already we know that B is our answer. C is not possible. D, acceleration equal to kx. Again it is positive, and our answer should be right. So what is our answer? Tell me, what is our answer? Of course it is B. B is minus k plus x, which satisfy the above condition. Simple. Answer is B. This is our simple harmonic motion. We know that how it works. We can plot graph x, b, and a. We will having questions on the graph also. Now, Sine cosine formulas, we need to remember these formulas. There are various tricks are there, we will discuss on that also. So sine pi by 2 pi when it is required, remember this all the formulas, right? Let's forward. Now next, example number 14, all India pre-medical test 2000. Two simple harmonic motions given by, first is given x, a sine omega t plus delta, and y, a sine omega t plus delta plus pi by 2. If you see here, both are having sine, and only phase difference. Phase difference is pi by 2. Phase difference is pi by 2. Fine. Act on a particle simultaneously, right? So these are the superimposed condition. Then the motion of particle will be a circular anti-clockwise. First is circular anti-clockwise. Second is circular clockwise. Third, elliptical anti-clockwise and elliptical clockwise. If these are the motion, we should know equation of first ellipse is asked and circle is asked. What is equation of circle? What is equation of circle? Is x square plus y square equal to r square? And equation of ellipse, x square by a square plus y square by b square equal to 1. Right? These are the two equation. One is circle and second is ellipse. If our equation x is equal to a sine omega t plus delta, y equal to a sine omega t plus delta plus pi by 2, if satisfy any of this condition, that means we can compare them. Okay, both are overlapping, x is this, y is this, right? Both are overlapping, right? So that means what? Final solution is x plus y. And we know that if we want to have some solution for that, so this angle should be equal, both angles should be equal. Both angle, how to make this both the angles equal? So we know that plus pi by 2 maybe there, plus pi, whatever this we know, we can change by using pi by 2 or plus pi by 2. So as sine angle, if you want to convert cos, so there are options. Sine pi by 2 plus x become cos. So it become a cos omega t plus delta. A sin omega t plus delta, a cos omega t plus delta. So we know that it is our equation. Let's check in this equation, x square plus y square equal to r square. Let's put that equation in this. X square plus y square, x is equal to this value. This is the value of x, it goes here, and this is the value of y, goes here. A square sine square omega t plus delta plus a square cos square omega t plus delta. If we take a square outside, what happen? It become cos sine square theta plus cos square theta, and sine square theta plus cos square theta is 1. So is a square. So this is x square plus y square. It is a condition of circle. That means it is a circle. That means option A and B both are possible. Now whether it is clockwise or anti-clockwise. This motion equation is x square plus y square is equal to a square. So theta means omega d plus delta equal to 0. So it is starting with 0. And y is equal to a. If you put this value, theta is 0. That means what? Sin theta x is equal to 0, y a, amplitude maximum, right? And after 90 degree, what happen? X is a, y is 0. So initially x is 0, y is a. If we take the circle, if we draw a circle, let's draw a circle. Initial condition x is 0 and y is a. That means this is the point. Starting with this, and after pi by 2 distance, what happen? X is 1. So x is 1. This is x direction. This is y direction, and y is 0. That means the body is rotating in this direction. Which direction? Which direction? Clockwise. It is clockwise. It is clockwise. Clock moves in this direction. Yes or no? Clocks moves in direction. So it is clockwise. right? So it is a clockwise direction. Answer is B. Answer is B, circular and clockwise. Yeah, good question. Now we have example number 15, All India Pre-Medical Test 1997. Oh, and long question. Two simple harmonic motions with same frequency act on a particle at right angle. That means acting of both the frequencies are having 90-degree angle, or simply we can say phase angle is 90 degree. Along x-axis and y-axis, if the two amplitudes are equal, means amplitudes are equal for both, a1 is equal to a2, phase difference is pi by 2. Two amplitude are equal and the phase difference is pi by 2. We can see from this statement also. The resultant motion will be circle, ellipse with major and y-axis, ellipse with major axis, along x-axis and a straight line. Do we know equation of all of them? Let's see. Equation of circle, x square plus y square equal to r square. Fine. Equation of ellipse, x square by a square equal to y square by b square. Equation of line, ax plus by plus c. Now, so we know that simple harmonic motion with pi by 2 phase difference, so it become x become a sin omega t and y become a sin omega t plus pi by 2. Directly you can also write sine and cos both are having phase difference pi by 2, so you can write y equal to a cos omega t directly. Or you may remember this, sine pi by 2 plus x is equal to cos x. We know that also. Great. So let's check for the first equation of circle, x square plus y square is equal to, let's put here x square sine square omega t cos square, so it become 1, x square plus y square is equal to 1. That means it is satisfying circle. That is circle. That is a circle. Ellipse no, line no. It's a circle. It's a circle. Simple harmonic motion of a circle. Question is very simple, but we need to solve this, right? And solution when it happen, when we have enough practice. Now next is example number 16 and NEET National 2019. The displacement of particle executing simple harmonic motion is given by, directly this equation is given, y is equal to a0 a sin omega t b cos omega. Oh, good. Then the amplitude of its oscillation. Amplitude, we need to find amplitude of this. Y a0 plus a sin omega t plus b cos omega t. We need to find amplitude of this equation. NEET National 2019. Okay, let's see. So we know the general equation, which is x is equal to a sin omega t plus b cos omega t, that we can write when there is a phase difference 90 degree. Phase difference is 90 degree. And here it is given y equal to a0 a sin omega t plus b cos omega t. Fine. Now what next? What should be the next move? See, from equation number 1 and 2, see, this remaining portion is similar. Remaining portion is similar, right? Here we can say that x0 a0 is the value of mean position. A0, it is given as a mean position, center position, mean position A0 at which y is equal to 0, at which y equal to 0. Therefore, this is just a constant value. It is not coming into picture. Omega t is 90 degree. So amplitude r is equal to a square plus b square 2ab cos theta. If you want this, so we know that both functions are having 90 degree angle. It become, then only you just need to have a square plus b square and we need to find this. So answer number a square plus b square, that is our correct. Example number 17. What is? A particle executes linear simple harmonic motion with an amplitude of 3 centimeter. Here amplitude is given a 3 centimeter. When the particle is at 2 centimeter from the mean position, that means x value is x given 2 centimeter, the magnitude of velocity v at x equal to 2 is equal to is that of its acceleration. That means acceleration at a is equal to 2. Oh, very simple question. Then it's a time period. You find out time period. What is time period? In a second. So we know that time period you can find t is equal to what? What? T equal to 1 by f and omega equal to 2 pi f. So you need this any of value, you find omega or f, or directly you can find t. So time period is required to find how it works. Let's see. NEET 2017 the question was asked. The time period it is root 5 by pi, root 5 by 2 pi, 4 pi by root 5, t 2 pi by root. Fine. So we know that magnitude of velocity, how the equation is given. We know that omega v is equal to omega under root a square minus x square, that we know. And magnitude of acceleration is given by what? A is equal to omega square x, that we know, right? We have used negative, but when there is equals are considered, so maximum value, so at that time we can take mode of both. What is given? When x is equal to 2 centimeter, velocity and acceleration both are equal. So v equal to omega a square minus x square power under root. Acceleration is equal to omega square x. So at x is equal to 2 centimeter, we need to find the values. Put the value omega under root a square minus x square. We can just remove this omega, so it is cancelled. We can take a square minus x square is equal to x square. Right. So omega is equal to a square minus x square by x. We can put x equal to 2. A is equal to 3 centimeter. Let's put and we can find omega. Omega is equal to under root f by 5 by 2. Omega is equal to root 5 by 2. Right. Then we need to find here what we need. We need here time period, that means t. T equal to 1 by f and f. What is f in relation with omega by pi? Fine. We have t is equal to 2 pi over omega. Let's put here the values and the answer is 4 pi by root 2. Answer is C. 4 pi by root 2, no root 2 root 5. Right? So it is simple question. Seems simple, but when you have all the example mixture of that, you should have your mind with you. But through practice, you can do it. And next is example number 18. A simple harmonic oscillator has an amplitude is given A and time period is T. Time required by it to travel x is a to a by 2. That means half. Suppose object which is having middle position. This is a middle position. This is end position. X equal to 0. X is equal to a. Right. When it travels to here somewhere, x equal to a by 2. Right. From this position to a by 2 position. A by 2 position. Right. We need to find time required. Time required. Right. Full time is time period is t and that is required. So we know that x is equal to a sine omega t, right? Then what? We know that x is equal to a sine omega t. The full omega t is always 2 pi by t. Omega is equal to 2 pi by t. You can put here also, you can put later also. At x is equal to a sine 2 pi by t. At x is equal to a sine 2 pi by t. Let's put here. So a is cancelled. A is cancelled. Sine 2 pi by t minus is equal to 1. So 2 pi by t you can put here, and the solution is x is equal to a by 2. So at t by 4 initially, and x a by 2. So first condition at x is equal to x is equal to a. This is the condition we received here. T is equal to t by 4. T is equal to time required for the first condition is, let's say, t1 t by 4. Now we are finding a is equal to 2. A is equal to 2. Let's put the same equation here. A by 2 is equal to a sine theta 1 half. So sine 2 pi by t, that become 1 half. So 2 pi by t, it become pi by 6, and t is t by 12. And ultimately, hence, time taken to travel from x a to a to 2 by 2. So it is just a difference between t by 4 minus t by 12. So it become t by 6. Answer is t by 6. Ultimately, simply we are putting just value of a equal to here. Sorry, x is equal to a for first condition, and second is x is equal to a by 2, and we are equating this equation. Nothing else. It is very simple. Now we have example number 19 with us. A particle is executing simple harmonic motion. Its maximum acceleration is alpha. Alpha is acceleration maximum, and maximum velocity. Maximum velocity is beta velocity maximum. Then the time period of vibration will be, right. So when acceleration is maximum and beta velocity is maximum, so time period of vibration will be all India pre-medical test. Alpha square matlab a square by velocity square a by alpha by b beta by. Okay. So equation of motion, we know that x is equal to a sine omega t, right, and from this you can find out value of that. So magnitude of velocity at displacement x from the mean position, velocity is equal to beta, and maximum velocity occurs at middle position, at center position, right. Object moves from here middle position, it goes up direction upward. So here velocity is 0, v is 0, here v is maximum, again going down, v is 0. Right, middle position v is maximum, and maximum velocity is equal to a omega. And second is acceleration is a omega square, which is maximum value. If we equate this to dividing this both the equation beta by alpha, so alpha by beta, we can take a omega square, omega 1 omega will be cancelled, a is also cancelled, so omega is equal to alpha by b. Do we need omega? No. What we need t. So t is equal to 2 pi by omega. Let's put value here. So it becomes 2 is equal to 2 pi beta by alpha. 2 pi beta by alpha. And our answer is D. T 2 pi by beta alpha. Thank you very much for watching Physics Doctor. You can subscribe our channel.